Several announcements. Okay, let's get started. Several announcements. First, first, next month, we will have a guest lecture from Charles Schwab. So he's back. So he's a team lead of their security operation center. So he will give a talk about how real world SOC works. So SOC is not only the big screens you see in the movies. SOC is actually a big security team, handle all the security incidents in a company. So he will give us a talk. So he attended our IA symposium last month. So if you attended his talk, shoot me an email. You don't have to be here. But I will bring an attendance sheet for that. And also, next Wednesday, we are going to have a quiz 4 covering firewall, IDS, authentication, and there will only be multiple choice questions and more like concepts. And the tentative final exam date would be December 7th. I haven't got the final confirmation, so I will update you guys when I got the final confirmation. So for the rest of the class, there are still several topics I want to cover. First is web security. We will start today, and a limited network, especially Tor. And from there, we're talking about the current landscape of cyber crimes and the underground economy. So usually they are associated with Tor networks. So today we will start with web security. So for a lot of users, they believe web is the internet. But from this class, I hope you know that web is not the whole internet. There are a lot of stuff in the internet has nothing to do with the web. And web is just a sublet of our current internet. But it is getting more and more usage and also attention. So web started in the late 80s when Sir Tim Berners-Lee invented web. When he was a software programmer at a physics lab. So when he worked there, he realized a lot of researchers, physics, they go to the lab, but they don't know how to share information. So as a software developer, he came up with the idea to just transfer text and graphics, images in some kind of form. And he called that web. So web follows a client and a server model. So there is always a client, usually the browser, and the server, which is a web server, and they will use HTTP to communicate. And to represent those text and images, he invented HTML based on text markup language. But markup language was not his invention. He invented HTML, which is a hyperlink markup language. So at the beginning, he had a very short proposal to his boss in this physics lab. And you can download this from internet. It's just several pages. And in this proposal, he envisioned this idea of web. So when we say he invented web, what exactly he invented was just 3 things and 2 programs. The 3 fundamental things we are still using today, HTML, the hypertext markup language, URI or URL, and also HTTP, the protocol based on TCP. And he also developed two programs. One is the first browser, and another is the first web server. So the web server we're still using today, HTTPD, with a lot of upgrades. So URL, we studied that before. So part of the URL is a domain name or host name. So it's not the IP address. But he didn't invent DNS. So DNS was actually invented in 1985 or a little bit before that. But he utilized host name and domain name and put that as part of the URL we are using today. So HTML is a markup language. If you are not familiar with HTML, basically there are a lot of tags, and each tag can have different attributes. And if you are not familiar with all this stuff, you can go to 3wschool.com. They have very good tutorials on all the web stuff, from HTML to JavaScript, even server-side programming. So HTTP is a protocol used between client and the servers. Basically, it's on top of TCP, and it is a request and a response loop. So the client keeps sending requests to the server or to many servers, and the servers will respond to the client, the browser, and the browser will collect all the things it receives from one website or several websites, and to render a web page for you. So the HTTP protocol, usually they have, the format is kind of like the email thing we talked about, because they are both application layer protocol. So the first line of HTTP protocol is a command. This is a HTTP 1.1. There is a get command, and this is a web page the browser wants to get, and also the version numbers. And after that, there will be a lot of headers. So basically, each header entry is just a key value pair, including host and also user agent, telling the web server what kind of software I am using and what kind of a web page format I can receive, language I can receive. And when the web server received a request like this, it will pass this request and respond to it, and the format is very similar. The headers starting with the protocol number HTTP 1.1, and 200 OK means nothing is wrong. If there is something is wrong, usually like 404, page not found, it will show here. And the other headers talking about the size of the content, and the actual web page will be embedded in this response as well after 2 new lines. So HTTP 1.1 is the one we are using, but 2.1 is also coming out, and some websites already adopted 2.0 or 2.1. So in that format, even though it's application, it's also an application protocol. A lot of things have been encoded to make the message shorter. So at the beginning of this web, so when Sir Tim invented it, it is just a static websites. And usually a webmaster will update the website several times a week, something like that, when he has something new. So to be this kind of a webmaster, you only need to learn how to use HTML. And so those websites are usually called a static website because they are not dynamically generated by any program. So the webmasters they can use some tools or they just write HTML code. But the website would be the same for everyone who access it. There is nothing dynamic. So how it works, any user, they want to visit vacation.html, and it will send an HTTP request to this server, and the server will retrieve this HTML and also pictures and embedded everything together into the HTTP response back to the user's browser, and the browser will render the web page using the received message. So it's quite possible that the web browser will make multiple requests. For example, in this case, the web browser first makes a request for vacation.html. And in vacation.html, there is an image tag saying there is a picture.jpg. Then the browser will pass that. The browser realizes in order to render this, I have to get this image. So the browser will send another request to the server saying I want this image. And the server will send the message back to the browser, and the browser starts rendering this. So usually for end users, if you just use the browser, this part is transparent to you. You only type in the URL there. You don't know there have been several web requests under the hood. So this is how it works. So in modern web, there are more resources, not only text and images, but also JavaScript, also style sheet. So all of this need to be retrieved multiple times by the browser. And sometimes all those resources, they are not hosted on the same web server. So it's possible that you type in a URL, but eventually your browser will send requests to several different websites to retrieve the resources to render. And there are several different HTTP request methods. Usually we are familiar with HTTP GET. That is what we saw before. And there are also HTTP POST. So if you say a form like this, whenever you input your password or reply something to leave a message, usually they are using HTTP POST. And if you just click a hyperlink, usually the browser will send out a HTTP GET message. And all of this, so how does your browser know it should send a POST or GET? That's because it is specified in the HTML. So in the HTML, for example, this one, it says methods should be POST. So when you click this button, the browser will interpret that you are clicking this button, and I am supposed to send this form. And I'm supposed to send the form using POST method, and it should be sent to this page. So this is a PHP dynamically generated page. So at the very beginning, like we said, web, they are static. Obviously, they can only be used to share information, not even some secret information. Because if you want to put some kind of authentication there, that web cannot support that. So we may need some kind of dynamic website which can dynamically generate content based on who you are, what you want. So it started like 1995. There are several programming languages. I'm not sure if PHP came that time, but Microsoft, they have their, I don't remember what is the language they use.
Most of them were CGI.
Yeah.
So you had the CGI and they were mostly C or Perl.
So basically it's a binary. It's a binary program. They just want to hook the binary include the binary program with the web front end there. Yes. So that's what they started at the beginning. So now we have all kinds of server-side programming languages, including PHP. So when a user wants to visit a website, it wants to visit something like vacation.php, not a static HTML anymore. And the browser will receive that HTTP request, and it recognizes that this user is requesting this page, and it will run that PHP, which is actually a program in that server. And usually that program is called a script or server-side script. But there are cases you can use CGI programs, just the binary programs. And then the server will generate a web page, a HTML, using that script and send that HTML back to the browser. So basically, dynamic websites, they have to use some server-based programs. Usually they will read something from the database and also may talk with other web servers, and they will output HTML and send it back to users. So the difference between this dynamic and static web pages, this dynamic web page, they are created at runtime by a program. And that program is obviously developed by some web developers. So to make the web even more powerful, around 1997, we have a client-side script. So we do not only make the server-side dynamic, the client side can also be dynamic. So the language we are still using for all our browsers is called JavaScript. So using JavaScript, the program can manipulate the web page. So after they download the HTML, the JavaScript will be embedded there, and that JavaScript can manipulate the web page to move things around, to show some images or hide images, and they can also send and receive HTTP requests. So one of the feature which is widely used today, called AJAX, is you have to use JavaScript to achieve that. So basically, imagine previously the websites are static. No matter it's static or no matter it's dynamic, when you want to exchange some message with the server, you have to send a HTTP request. But when the browser receives that HTTP request, the browser will update the whole web page in the browser. So for the users, it's like a refresher. But it happens that the browser or the program, they don't really want to update the whole web page. Only part of the web page should be updated. So in that case, the browser should still send the HTTP request, but it will not getting the full web page back, just a part of the web page, and just replace that part in our current rendering. And that is achieved by the technique called AJAX. So basically, there is a script, a JavaScript piece of program that will send out a message to the web server, and the web server gives back a piece of HTML and replace that piece of HTML with the old ones. So here is another JavaScript piece. So this one is just trying to change the text in a web page. So first, it will try to find the tag with ID demo and change that text to text changed. So it can do all kinds of things. It can also access cookies, and this would be a fundamental reason we need web security, a lot of security issues. So after that, the major components of our current web are there. So our current web, we call it web applications because those web applications are so complicated. They are distributed. One web application may involve multiple server-side script and also user-side script, and there are many security problems. So even though the communication side, we already studied that we can use HTTPS, which is based on TLS and SSL to protect the communication channel, and also can use this to verify the identity of website. But there are many problems cannot be solved by protecting the collection. So first, the website, they could be compromised. So when a website is compromised, attackers, they can simply put some malicious code there. And that malicious code usually is some malicious JavaScript. And that JavaScript will be executed on the user's browser. And that JavaScript can be used to carry out some kind of attacks against the browser itself. And if the browser is compromised, the browser can download additional malware, and that malware could be just a binary code. And that additional malware could compromise the whole operating system. So usually users, they do not make any mistake. They just type in a malicious website URL, and all of the attack happens without the user's interaction later. So that kind of attack is also called a drive-by download, because the users they didn't really do anything stupid there. They just type in a URL, and all their computer can be compromised because there are bugs in the browser and also in the operating system. Yes.
How does the downloaded file get run?
So usually that is because the first step is to download some malicious JavaScript, and the JavaScript will be run by the browser. But the browser usually also have all kinds of vulnerabilities that can be exploited. So the JavaScript will try to exploit those kind of vulnerabilities. And after that, usually they can run a very small piece of code, like binary code, in the browser's process address space. Then that piece of code can download another additional malware, an additional exploit, try to exploit because it's not in the sandbox. It's in the browser's address space. And in the browser's address space, they can try to exploit the operating system. So if the operating system is compromised, they just take full control of everything. But it starts with the JavaScript.
So you need an exploit in the browser to run anything else.
Yes. And there are other security implications as well, which you cannot need browser to exploit, but you cannot take over the whole operating system. So this is another kind of vulnerability is your browser may talk with multiple web servers at the same time because you open so many web pages, and the JavaScript from one web page may be able to do something malicious to steal things from the other web page. For example, there is evil.com. The JavaScript from there may steal things from the other tab you are opening from BOA.com. So those are all the security problem we have for web applications. And the problem is getting more serious because now we are not only using HTTP, we're not only using browsers to use HTTP. Actually, all the apps we are using, the Android apps, the iPhone apps, they also use HTTP to communicate with their servers. So previously, those could be servers running other protocols, but now everything is running HTTP. Everything is just XML or HTML. So all those apps, they have the same problem we had for browsers. So the JavaScript could exploit those apps, and JavaScript can steal other websites' information. But also because apps, they do not usually enforce the protections used by browsers. The problem is getting more complicated now. So it's like the boundary between apps and browsers, it's not very clear right now. So there's a lot of problems there. So if we want to provide a secure web, there are some security goals we want to achieve. First is confidentiality. And this confidentiality is not about the communication channel, because the communication channel has been protected with TLS. So the confidentiality here we're talking about is any malicious website should not be able to learn any confidential information from our computer or the other web pages we are visiting in our browser. So there should be some boundary. So it's very possible that you visit some malicious website. But even if you visit that malicious website, there should be some local mechanism to stop those malicious websites to steal your files on your hard disk, and also steal your BOA information, which you are collecting using another tab. And another one is integrity. So any malicious website should not able to change anything on your computer, and also your BOA's web page, something like that, and also privacy. So malicious website should not be able to spy on you to see your other activities. It should not be able to know what other websites you are visiting. So the first thing is we don't want any website, could be a malicious website, to infect our computer with malwares, read-write our computers, and this can be done with that drive-by download we explained before. So basically, some JavaScript can exploit the browser and then exploit the OS. We don't want that to happen. So usually, the way to defend this kind of attack is use sandbox to confine what the JavaScript can do, and also when we find any bugs, explorable vulnerability in the browsers, we should be able to, we must fix them. And also, we use all kinds of software defense techniques like address space layout randomization to make it harder for any exploit to work. And so basically, this is what we are doing and what we can do for those kind of drive-by download attacks. And the second kind of attack is something like evil.com. They should not be able to see my emails in my Gmail, or buy stuff with my Amazon.com account. So this is achieved with a principle called same origin policy. So we will talk about what is same origin policy in a moment. And the third one is the data stored on web servers should also be protected from unauthorized access. But this part usually has nothing to do with the end users. We have to use server-side protection mechanisms to protect that. So we are going to talk about what is same origin policy. This is like a very important concept in the browser. So basically, it's a policy enforced by browsers. And the different browsers, they may have a slightly different same origin policy. But the basic philosophy is the same. So the idea is the code or whatever from one origin should not be able to access the resources from other origin. So when we say code, we are talking about JavaScript code, because they are the only code can be executed in the browser right now, can be downloaded from the web server, and can be executed on the browser. So basically, this policy says that JavaScript from one website should not be able to read or modify pages or other resources from another website. So origin in different browsers, so there is no standard for this same origin policy. But usually origin is defined by three things: protocol, hostname, and post. So basically, the origin of a JavaScript is derived from the URL it was downloaded from. So let's say we have a Wikipedia page, and we downloaded the whole HTML from this URL or hostname. So this will be the origin for the whole HTML page. However, the image in this web page may be downloaded from another web server. In this case, will be upload.wikimedia.org. So you can see that there are two different hostname URLs. So basically, this HTML and this image, they have different origin. And the same, but here, those two things, they are static. They are not JavaScript. So if there is a JavaScript, which means that JavaScript should not be able to change this web page if the JavaScript is from upload.wikimedia and the web page is from wikipedia.org. So let's see one example. So we have some JavaScript embedded in a web page, http 3w.example.com.dir/test.html. There is some JavaScript in this HTML, and that JavaScript should be able to access a web page from this URL. Because you see, this is the origin of that JavaScript, and that JavaScript is using the same protocol, HTTP, and the same hostname, 3w.example.com, and the same port number, because it's not here, it's port number 80. So that JavaScript should be able to access and change this web page in the browser. This is only enforced in the browser. And the second thing, the second URL is the same, because they have the same hostname, protocol, and port number. But the third one, you can see that the third one is using port number 81. So they are from different, according to the browser, they are from different origin. So that JavaScript from here should not be able to change this file. And the fourth one, they're using a different protocol, HTTPS. So the JavaScript should not be able to access this. And this one, they are using a different hostname. Here is 3w.example.com. Here is english.example.com. And also this one, they are different hosts. Here is example.com. Here is 3w.example.com. But cases like this, JavaScript, they may be able to bypass protections like this, because they can manually set their host name there. This one the same because they are different host names. So more example, let's do some test. So this is the originating document. JavaScript here, and the JavaScript here, access this document here, change this document. Yes or no? Yes, okay. So how about the second one? Yeah, it should not be able to, but this kind of cases are tricky. Depends on how browsers, depends on the APIs browsers offer to the JavaScript code actually. Yeah. And about this one, no, because they are using different protocols. And this one also no, because they are using different port numbers. And this one also, because this one is port number 81, and this is port number 80. So this is the basic principle of single origin policy. Yeah.
Is the third case like necessarily a bad thing though?
It's hard to tell actually, because the single origin policy has been evolving in a very ad hoc way. Different browser vendors, they use slightly different single origin policy. But for the website, they don't know that, right? So it's like we're looking at the same web pages, but every browser is treating that problem differently. So there are a lot of problems. So it's hard to tell sometimes which one is a better choice, which one is not. Yeah. So, but all of the browsers, they are enforcing something like that, even though they are slightly different. And the single origin policy is like the basic policy in browsers to isolate web pages from different sources. So the policy itself, it's not as simple as what we said here actually, because there are many different resources used by modern browsers. They can use cookies, they can use script, they can download the new HTML or XML, and they can send the HTTP request, different types of the HTTP request. So the single origin policy for different resources in different browsers, they are all different. And even some browsers, they have different definition of the origin. So previously we say that origin is a protocol, host name, and port numbers. Some browsers, they may enforce something more strict by considering other parameters as well. So the next class, we're going to move to the server side first. We will talk about the secure injections and other injection vulnerabilities on the server side, and also cross-site scripting part. So web security is actually a very unique. Web is a very unique application. It's different from our other applications.